I want you to imagine with me that you and I are walking down the sidewalk together having a conversation, and a limousine pulls up. Man in a suit and tie and dark glasses gets out of the back and hands us a suitcase saying, I'm going to give you $250,000. I want you to go build a service provider network that can connect my 15 offices in this city together. What do you do? No, you're like, run! All the advice our parents gave us of taking candy from strangers. Don't take $250,000 from a stranger, or grab the $250,000 and run anyway. But nonetheless, for real, if we're thinking about designing a service provider network, where do you even begin? What does a service provider network look like? That's what this nugget is all about. We're going to look from a big picture, like what is a network in general? What is it designed to accomplish? And then blend that into how does this look in a service provider environment by the time we're done. Let's start off and ask the question from a service provider perspective, what is a network? Well, networks in general are just a modern form of communication for humans. I know it sounds funny to say it that way, but if you think about it, at the end of the day, all a network does is facilitate some form of communication from one human being to another. Now, that communication could be grand, it could be a photograph, it could be a music library, but at its root, it's communication, right? And the bigger network we have, the more rules we need to have to govern that. Think about this. If you look at a meeting room, it's a form of communication, right? If Bob comes in and sits right here and Mary comes in and sits right here, you don't need that many rules if those two are going to communicate because it's only two people that they can kind of figure out how it's going to go. If they accidentally interrupt, they'll say, "Oh, I'm sorry," and they'll start over and communicate. But let's say that we move this meeting room table from 2 people to 1,000 people, right? Now you have to have rules that govern that, because if everybody comes in and just starts sharing their opinions and communication together, it's going to be absolute chaos. Maybe you pick one person right here to communicate to everybody, the one-eyed man that's communicating to everybody. You've established a rule, but you've changed it. Instead of being a meeting, it's more of a presentation, right? The one communicator is communicating. But if you want everybody, then you're going to have bells or something, or raise your hand in the air and have some person elected to choose who's going to speak at any given time. Well, now take that concept and apply it to computers. We have devices, we have computers themselves, we have laptops, we have wireless access points broadcasting signals around a network, we have voice over IP phones, we've got, again, now we're moving into thousands and thousands and thousands and millions of devices that are all connected together on this giant network that we know as the internet. Or you can take it smaller and say a corporate network or a home network. Regardless, we have to have rules that govern that communication. That's where you start having standards come out that says, okay, we have something called Ethernet. You ever asked yourself, what is Ethernet? Most people, if you're like me, go, a cable, right? Like you plug in a cable. Well, no, Ethernet is a standard. And what is a standard? A list of rules, right, that govern communication. You start coming out with rules like CSMA /CD, and I know some of you are like, no, it's getting too technical already. Well, that's okay. It's just a rule. All this is saying I'm going to sense if somebody else is sending. That's carrier sense, multiple access, and that's what allows many people to be connected to this common sending media at a time known as Ethernet. And if the 2 people send at the same time, then I'm going to be able to detect that. That's CD, collision detection. All it is a list of rules that are in place to make sure that our communication will work the way it's intended. So when we take all these thoughts and apply them to a service provider, things just get bigger. I talked about one rule right here, CSMA CD, that governs Ethernet, but we're moving our conference room into the size not just 10 or 100 users, but potentially millions of users. Because when I talk about service providers, most people don't just say SP, they say what? ISP, Internet Service Provider. As in, we are connecting and we are bringing internet access to all of our subscribers, which means that our network could be potentially traversed by millions of people. And that just means there's a lot more rules, right? We've got to know more, understand more. But at the end of the day, a service provider is just a network. I really want to emphasize that early on, that a service provider is just a network, because I find if you demystify it, it's so much easier to understand. Think about it this way. When people draw service providers on a network diagram, what do they use? cloud, right? You say, this is my ISP, and then you draw a line to you, and that's where you get detailed, and you say, okay, well, here's my server over here connected to, you break apart your network diagram, but you just think of this as cloud is magical. I request cbtnuggets.com, and poof, it's handed back to me. Magic, amazing how that happens. Well, if you talk to a magician about a card trick, he shows you something, you're like, wow, that was amazing. You made that card disappear. But if you talk to the magician, is he amazed? No. He's like, well, actually, I just used my thumb and moved this back here, and now you can't see the card. Now, when you're like, oh, well, I guess anybody could do that if you practice enough, right? And I'm not trying to burst your bubble and be like, ISPs aren't cool, but I'm trying to demystify it just to say it is just a network. The concept is really simple, at least from a big picture, to where an ISP is just a network, just like you're drawing in your little house or your business down here. They're just a network that's connected to another one, and another one, and another one, and another one, and they just have to have rules that govern all those connections so that they can make sure, one service provider that does something wrong doesn't impact all the rest of them. And welcome to the rest of this series. That's all ISPs are. So now let me talk about Cisco. Who is Cisco? Why are they... why am I here? Well, Cisco is the debated inventor of routers. And the only reason I put debated on there is if somebody goes out and says, okay, well, let me check, and they go to Google. Of course, you'll see Cisco invented the router, but then there's 15 other people that are like, no, I created it and Cisco took it from me. So, whatever, scandal you want to believe, we'll go with Cisco was one of the first to create the routers, and they are the ones that ran with it, right? They took this device that they created and built, now known as some of the most stable network equipment in the world. And let me combine this together by standardizing on software, okay? First off, let me start off by saying this. Will you pay more for a Cisco device versus another vendor device? Chances are good that I can say yes, you will. Now, when you are paying more, what you gain from that is, oh my goodness, I could just fill this screen with benefits of this that is just intangible. Let me just give you a couple. Number one, you gain that standardized software. There is a time is money effect or impact anytime you go with another vendor. So let's say you've got Cisco firewalls in all your data centers, and all of a sudden you decide to go with vendor X because they're a couple $1,000s cheaper for a device, or a couple whatever. I just threw a value out there, whatever amount cheaper. Well, now you come in and you have a technician who gets a device and he's like, well, this doesn't use the iOS, Cisco standard software. It's got a GUI. And, okay, well, how, so he's now having to go, get trained on this device and understand this device. And now he's the specialized one that works on it instead of, having the standardized one. Think of, would any company in their right mind decide to just say, hey, I'm going to, do a mix. Let's have a mix of Windows and Linux and Macintosh. And we won't really, pick one. We'll just, whatever somebody wants to use that, I know some of you are like, well, that kind of describes my company. No, it shouldn't be that way because it's so difficult to support that kind of environment. You have to find a standard. Most people know Windows. We're going to have Windows in our environment, or whatever standard you choose to do. So it's the same thing with network devices. If the more you mix and match, the uglier it gets to learn to manage. But also, let's talk about stability. The fact is, Cisco has a track record of being one of the most stable devices in the world. And why? Because they're so huge. And there's so many people that use them. Now, let me give you an example that I ran into. I drew up that little goofy pie chart where saying Cisco is over here, everybody else is all these slivers. Well, I actually did go buy vendor X equipment mistakenly for one of my network environments, and I ran into a bug. And I'm not saying Cisco doesn't have bugs, but let me play this out. When I ran into the bug with this vendor, I was on the phone with tech support, showing him I figured out how to make the bug manifest itself, and the guy goes, wow, I've never seen that before. Let me escalate you. Now, hearing that statement, you and I may be like, oh, he just hasn't seen that before. And yes, I agree. But can I tell you that it got escalated and escalated, and it's still right now unresolved in their tier 9 environment or something where they're investigating this bug that I ran into. You just don't get that with Cisco environments. And now, I'm not saying you'll never be escalated, but when you're here with tens and hundreds and thousands and millions of different devices and users of Cisco that when you run into a bug, and there are bugs, I'm not saying Cisco's bug free, but when you do run into it, chances are very good you're not the first, that you are one of 100 different people that have run into that. And when you call in, they go, oh yeah, your bug ID 5596, you need to upgrade to version 5.9. Whatever the case is. They've seen that, they've been there, they've done that. You don't have to spend the time having Tier 9 develop some custom solution for you because you're the first one to find this bug. Trust me, I could go on and on with the benefits of Cisco, but those are some of the big ones that come to the top of my head. So let's talk about the network structure itself and really network diagrams. Service provider networks are going to be built with a variety of equipment, but I'll say the most common is going to be switches, routers, wireless access points, and clients and servers. So rather than have network diagrams where we put these physical devices on there, which becomes cumbersome, we represent them by icons. So we will have network diagrams a lot of times where we will have a switch, and I obviously will not draw them by hand every single time, connected to a router with an Ethernet cable. And if you're brand new to networking, can I mention a lot of times the switches are optional. If you're not talking about a switch in a discussion, they'll often be abbreviated with a line. So here's our router, connecting off to the service provider, or we are a service provider, or maybe we're in one. We might draw it something like this. So here's a cloud going to a router, and then we'll just do something like this. So essentially the switch becomes just a connection line because we're not focusing on the switch in that discussion. While we often see our network diagrams represented like I was drawing on the previous slide, of here's our switch, here's our PC, and here's our server, and things like that. There's our router in the network environment. There's actually a whole physical infrastructure behind this that's never shown. And I want to make sure everybody's on the same page. If you're like me, I actually came long ago from a server background. I was in Novell and Microsoft and those technologies, and then I moved straight into Cisco, and I actually had a big gap in my knowledge for years on cabling. I just took for granted oftentimes that I would plug into a wall jack and just connect it to a device, and there it is, it works, and okay, life is good. And if there was anything wrong with that, where my light didn't turn on my device, I would say, okay, well, call the cabling guy, until I found out they go, you are the cabling guy. And so in some cases you may have to deal with the cabling as well. So in a network environment, you usually will start from the IT room, which typically is called the MDF, main distribution facilities, or IDF, intermediate distribution facility. So and this goes for service providers just as well as it does in businesses. Let's just take a building, right? The MDF is the place where it's your main place. I was going to say, I'm trying to think of a more creative word, but really, main describes it all. This is your main location for your IT equipment. And you might end up having, this is, let's say, floor 1 of your building. Maybe on the second floor, you don't have to have all the same firewalls and servers and things like that. So you just run a line up to the second floor, and you have a much smaller IT room up there where it just houses some switches, might look something like that. And they call that an IDF, an intermediate distribution facility. And inside of there, you'll have a structure that looks like this. Now, trying to think where we would start here. Right here, I know it's difficult to see, but at the bottom of that rack is a network switch. Now this is a Cisco device, I'm hoping, that is inside of there that we manage and that this course is all about. But we will usually take that switch and patch it up to a series of appear as patch panels. Now, patch panels are physical devices. There's no intelligence. Oftentimes, there's not even electricity to them. They're just a physical device that on here, we connect, we patch. A lot of times, you'll say you patch your switch into it. You connect an Ethernet cable to it. And then behind it, we can't really see it here, but this is looks like a big old conduit where we run all the cables of our company. So you go to cubicle A or conference room B or lobby, and you have this wall jack where you run all this cable from the wall jack, and it all comes down and terminates here. So this is the central point connected to the patch panel. The reason we do that is because if you connect it to the switch and then you have to move the switch later, you then have to yank all this cabling out of the ceiling, and it becomes a terrible thing to do. So we use a patch panel as kind of this junction box in between our incoming network cable and the switch. So it goes into the wall jack. You connect from your wall jack to the device, and hopefully that device now has internet access. So again, all of this stuff is behind the scenes. You don't see this in the network diagram, but it's there. If you do want to dig more into those physical Ethernet characteristics, I actually created a series for CBT Nugget some time ago called Ccna for the Real World. I would really suggest going and checking that out. I created that series essentially out of, I've taught CCNA and a variety of the CCNAs, and I almost made a subtitle for that series. Everything the CCNA program doesn't tell you. In the sense that a lot of times you'll go through the CCNA, you'll get certified, and then you'll go into the real world, and you're like, oh my goodness, I didn't even know I would have to do this or that. So that's where that CCNA in the real world series came from. So again, this is another perfect slide. If you want to dig deeper into some of these concepts, you might check that out. The reason I'm bringing it up here is because it's on the exam. I'm not trying to think of a nice smooth way of saying that, but Cisco does require this knowledge for the CCNA service provider exam. Okay, so when we are connecting things together in an environment, a lot of times we'll use Ethernet cable. Ethernet cable, the benefits of it is it's extremely cheap, extremely easy to work with, extremely common, as in just about every server, every PC, every laptop device, router, switch, everywhere has Ethernet ports. This uses copper cabling to send network signals over it. A lot of times you can get into all the standards of it goes 328 feet or 100 meters without attenuation. But again, go to the CCNA in the real world, and I will tell you it goes a lot further in ideal circumstances. I've seen Ethernet runs of 500, 600 feet, and it still works a-okay. So it's like the Matrix. Some rules can be bent, others can be broken. Right? Very common kind of cabling, but now fiber is becoming very common as well. The beauty of fiber is, number one, we've moved away from copper into using light signal. Light is not subject to interference. So you can have 1,000 different fiber cables sitting next to each other, next to fluorescent lights and everything else, and it's okay. It's not going to be interfered with. It also can go a lot farther and be repeated. Like you can regenerate the signal infinitely. So you can go miles, you can go around the world with fiber optic cable, just regenerating that signal, and you'll have just as strong a signal at the very end as when you left. Now, again, I'm assuming no one's standing on the cable or anything like that. Whereas with copper, you have attenuation, like that signal degrades. So a lot of times fiber will pick up when you get into those 1 gigabit per second, and I'll even kind of say, you can do gigabit with copper, but usually begins at 1 gigabit per second, and that's where you get into the 10 gigabit, 40 gigabit, 100 gigabit per second links. That's going to be done using fiber. So if you have a very long connection, you'll use fiber, or if you have a very high volume, high bandwidth connection, you'll also do fiber. Lastly, and by the way, I'm going to talk about bandwidth and size and things like that in just a second. So the last one we have here is a serial cable. Serial cable is now, I would say, mostly legacy. And what I mean by legacy is old. I'm, again, finding these good words to say for it. Older technology, but a lot of times you will run into this in environments or areas of the world where they're just, it's not available. I mean, there's a lot of places in the United States where, you'll be out in rural areas, and the only thing that they have is a serial T1 connection available. So you're 1.5 megabits per second, 1.544. Or you'll be in other areas of the world where they have a serial X.25 connection. So there's a variety of legacy, old technology where until the world is fiber optic everywhere or Ethernet termination everywhere, we're still going to run into serial interfaces. But that, again, as the world gets smaller and smaller and the technology spreads more and more, we're seeing less serial, which what characterizes them usually far reach. They reach areas that you can't normally get to, but low bandwidth connections. Well, let me use that comment on bandwidth to springboard into a discussion of speed. Over on the right-hand side here, I have a list of what I would call sizes of storage that we typically find on computers. The one you and I usually begin with is something called a byte. And a byte is 1 character. So if you open, say, Notepad, and type in A on the keyboard, there's a byte. BCD, that's 4 bytes of information. So each character equals a byte. Now, if I take that and go to the next level in size, we use increments of 1024. It's about 1,000, kind of like meter, kilometer. Well, we go from byte to kilobyte, which in practical terms is if I were to take this screen and fill it full of text, that would be about 1,024 characters. I'm not going to well, let me save that. But fill this full of text. That would be about 1,024 bytes or kilobyte of information, and it follows that same scheme the whole way up. You go from kilobyte to a megabyte, which is 1,024 kilobytes, to a gigabyte, to a terabyte. And now, I mean, these are things that usually when you buy a new computer, you look for. You say, okay, well, this computer has, we'll say, 8 gigabytes of RAM and a 2 terabyte hard disk, which is, it really, I mean, puts in perspective about how much data it's able to store, which if we're talking just about pages of documents, it seems almost infinite in size. Now, our network doesn't deal with things in terms of bytes. It deals with it in terms of bits, which you and I would rarely use in a conversation if we're just normal computer users, because a bit is what computers use. It's the simplest form of logic. It is an on or an off. A 0 or a 1. It's binary. It's how computers work. If you go back into the original programming, if you went to a college, you would do your programs on punch cards, where you would punch out, essentially chads, if you will, from these punch cards to have on or off things, and you would feed the punch cards into machines. That's very old programming, and as advanced as we've gotten, it's still ones and zeros behind the scenes. It's still ons and offs, just kind of logic decisions, if-then statements. My grandmother recently passed away, and we got her entire encyclopedia library. And I was looking at it because she had an encyclopedia of technology, which was from back in the 70s or 80s. But the funny thing was, as I was looking at it, it was talking about how computers work, and it is almost exactly the same today. It's all just like if-then, on, off, this way or that way. It's all the same, just it looks a lot prettier and works a lot faster, right? So when we're talking about network speed, we rate our links in terms of how many bits it's able to send per second. So common link, you've probably heard this before, is 100 megabits per second when you're talking about a network. This is 100 megabits per second network connection or network cable, right? And one of the most common mistakes that people make, it's so easy, and you'll hear people, I've stopped correcting people. It happens so often when somebody says, oh, well, that's 100 megabyte per second cable. Now, I used to do silly things like, whoa, that's amazing, that's a fat, and I'd spaz because it's not 100 megabytes per second, it's megabits per second. And so let me ask you, if I said it's 100 megabyte, big B, capital B, per second cable, how many megabits per second would it be? 800, right? So it would be an 800 megabit per second link, or a gigabit or gigabyte per second link would be a gigabit. But I'm telling you this, I really want to emphasize this, because as a service provider, you will work with a lot of customers who will call you disenfranchised because they signed up for a 20 megabit per second network connection or internet connection, and they'll be like, hey, I'm downloading and I'm only getting like 2. Well, you have to quantify that and say, whoa. Are you talking 2 megabytes per second or megabits per second? Because if you're talking megabytes per second, then that's about right. You're getting what you're paying for. If you're talking megabits per second, then let's talk. There might be something wrong with your network connection. So all of our network speed is rated in bits per second, but unfortunately, all of the web browsers, I won't say all, but most of the web browsers will show you download rates in terms of megabytes per second, because they realize most people have no idea what a bit even is. Well, as we journey towards Cisco's model to design service providers' networks, we always have to take a stop at their 3-tier architecture. This model is probably as old as Cisco itself. This is their best practice way of designing a network, and it doesn't make much sense until you think about how networks normally grow. Normally, you have a switch and you attach a couple devices, your small office, home office network, and that does just fine for that small office, home office. But what happens when you hire more employees? The company's growing. Well, people usually just daisy chain another switch and attach devices to that, and that maxes out, and they daisy chain it. It just starts going like this. And the bigger and bigger that gets, the creepier it gets, because if any one switch dies, essentially it cuts your network in half and causes a major outage of that network environment until it's found and replaced. Well, Cisco says, no. How about we start it the right way by designing it in layers? At the access layer, we have where devices access the network. So if we were to take that small business, maybe they would have a couple switches here where the devices, so these are the switches, I'll just put S on there, devices access the network. Now, as it grows, you'll eventually create another tier a distribution switch. And this distribution switch, I mean, you can grow a company like this into the hundreds of users and just keep attaching, access layer switches. It's kind of coming down to this hub, which eventually that hub becomes a scary single point of failure. So you add a second distribution switch, and that's where you start seeing a model like this emerge. So where we have our devices plugging in right here, we have our cross connects, our distribution switch, and these are all connected together to where, we have this kind of environment. Whoop, wrong way. To where this kind of environment where any one switch goes out and it all fails over to another one. So you never lose connectivity. You attach your router here going off to the internet and all that kind of design. And eventually, you might grow this into multiple buildings to where you've got, this is building 1, and then you've got building, well, it doesn't fit here. How about we go here? Building 2, and this is building 1. Where, it's fine. I would say you don't really need a coordinate layer initially. You could just cross-connect the buildings. But what happens when you add another building and another building, another building? Eventually, your cross-connects become this big, messy, tangle web mess. So I'm like, what word? It's a mess. So you eventually move into a core layer, which is where you have multiple distribution layers connected together. So it just grows under a planned method that way, rather than just kind of daisy chaining one thing to another and just hoping, crossing your finger, that none of those devices fail. Now this model is showing switches and servers and things like that, but you can apply this model to anything. I could, cut these out and maybe go routers. Like, this is our Arizona office, and this is our Texas office. And again, this is early on in the series to talk about this, but this could go to a regional West Coast office division where there's a couple routers, and you've got your core, centralized. So you can apply this tiered logic, the 3-tier logic, to just about any network infrastructure you want to throw at it. All right, let's now move into a discussion specifically about service providers. Now, Cisco has created a model, they call it the NGN model, or Next Generations Network Model, to design a service provider network. But showing that model right now is just flat out overwhelming. So I wanted to do Jeremy's artistic interpretation of service providers first. What service providers do is aggregation, right? So here are their customers, define a customer of a service provider. This could be a home, a residential home, right? This could be a business, another business. This could be I don't know if you've ever heard of this, but a WISP customer, a wireless ISP. What that means is there's actually equipment now to where you can set up little towers and broadcast 802.11 wireless signal, wireless networks, to a regional area where people pay and they link into your service provider. So essentially you've got all of these customers, and all service providers do, I don't mean to oversimplify, but they take them and aggregate them. The bigger you are, the more aggregation points you have. So essentially the more neighborhoods you end up reaching. So here's, service provider, we'll just say this is all one service provider. Here's aggregation point 2, where they've got a whole bunch of customers. And we'll take all those aggregation points, which this could be a small building. I've actually been in sometimes they're called CO, central offices, that are in a dusty little shack in the corner of a neighborhood that people thought was an abandoned house. It's just one of those small things, or one of those squeaking, shaking lights hanging from a wire from the ceiling. And I've been in CO, central offices, for large metropolitan area where there's, dozens of full-time employees, glossy network equipment, the stuff that you see on Google Pictures. So regardless of what these aggregation points are, they all essentially tie back to the service provider's central source. We'll call it the core of the service provider. So question, okay, how do they do that? Like, what is this? Is this a big long Ethernet cable? Well, kind of. There's actually, many service providers who have dug up the streets and run most of the time fiber optic cable. I'll just put FO, fiber optic cable, which reaches these points, and then from there they stretch out and they dig up neighborhood residences to run their it could be another fiber optic cable, it could be copper cable, it could be a phone line. It depends on the kind of service provider you're talking about, the kind of carrier they are. And what technology they're reaching. I mean, that goes back to the discussion we just had on the previous slide of the kinds of network cables. Different ones go different distances. They also have different expenses. Remember, digging up streets and neighborhoods is not an inexpensive thing to do. Now, hold the phone. for a second, is this like unreachable territory for you and I? I mean, I started off this nugget by saying you've got the limousine. Somebody with $250,000 comes up and says, "I want you to start a service provider." But frankly, between you and I, $250,000 isn't enough if you're going to start, trenching streets and getting permits and all this kind of things. Can the common man, if you will, go out and start his own service provider? Yes, he can, because there are very few, oftentimes, service provider who have paid the expense to dig up the streets, right? For instance, I live in Arizona. There are only 2 service providers that have paid to dig up the streets. They are CenturyLink, formerly known as Quest, formerly known as US West. CenturyLink is one, the biggest one, and then there's another one called Cox, which is a cable modem service provider that has paid to dig up the streets. But there are a lot of other service providers in Arizona. But if you might scratch your head and say, well, wait a sec, if only CenturyLink and Cox have dug up the streets and run cable, then what about all of the other guys? Like, for instance, there's Integra is another one. There's Cable One, that is another one. I mean, I'm just off the top of my head. There's GetNet. There's just limitless service providers in this area. But how are they doing it if they're not digging up the streets? Well, what happens is these guys who dig up the streets will typically lease their lines. They don't just run one cable for themselves. They'll run a whole bundle of hundreds of cables, and they'll lease their lines to other carriers. So they'll essentially sell directly to customers. So you can call up CenturyLink and say, hey, I want an internet connection for my business. But a lot of times, CenturyLink will lease their lines at wholesale prices to other carriers, and I'll just leave them as nameless lines, and they will go and approach that same customer and say, hey, and we'll include such and such. Now, the way that government works, and I'm not going to go there, but the government says, okay, well, you can become a monopoly if you, because essentially you could undercut, if you're one of these ones that paid to run the cable, you could actually undercut all of these people that you're selling the prices to. So the government in the United States of America, at least, has set the prices and said there will be tariffed pricing, if you will, for these carriers. So essentially, they have to sell their lines cheaper to the other carriers than they can the customers. And I'll let your own opinions come in on the fairness of that. But anyway, that's that's outside of this course. But let me take all this whiteboard and now show you the diagram that I put together. This is kind of what it looks like. Essentially, you have what I would call aggregation nodes, where you have all of these different businesses, homes, cell towers, or whatever. Essentially, all of this is interchangeable. It's just a way of connecting. Could be wireless, could be cellular, could be phone lines, could be cable, television, coax cable, could be fiber optic cable. Whatever. It all comes out as what would be called an aggregation node that feeds into the service provider core. Now, what happens when you get to the core? Like if I've got all these little, you go bigger. Oh, wait a second. I'm drawing on something that doesn't exist. You go bigger, 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 bigger. They're all feeding back here like this, pyramid scheme. You get back to the core of the service provider, and then the service provider links to other service providers. They bring up high bandwidth links. So let's just say we create our own service provider called CBT SP, right? CBT Nugget Service Provider. And we would get links to other service providers, CenturyLink, Cox, GetNet, whatever, all these other service providers that we would create links to from there, and then we would essentially, we become a reseller, if you will, of their internet service, and so on and so forth. So it just gets bigger and bigger and bigger until you get to the very in this you could keep following the scheme. Now I know some of you might be thinking, wow, this is a no-brainer. Some of you are like, my goodness, I want to go create a service provider myself. So I know I'm talking to a gamut of different people, but this is how the service provider worlds until you get to these giant providers like in America we have Level 3. They're one of the big guys, if you will, level 3 technologies. And so, those are the ones that, the CenturyLinks link to and the Coxes link to. And so they are kind of, if you were to say the middle of the internet, if you will. Now, what, I know some of you think with minds like I do, well, what if I run in and blow up level 3? Do I take down the internet? No. No, you don't. Because all these other service providers connect to each other. It's a giant mesh, if you will. So it would recover. Could you cause major slowdowns in the internet? Probably, because, this is where all the high bandwidth links is going. And I don't mean to promote any one carrier. I'm just using level 3 because I know them off the top of my head, but there are others as well. But it's just a big old pyramid scheme. That's how these service router networks work. So here is the Cisco Next Generation Network model. And now you see why I wanted to give you my artistic interpretation beforehand, because just showing this out of the chute can be plain overwhelming. So here's what I was calling those aggregation nodes. They call it this access layer. And we're actually talking about access, distribution, core layers of network design, which we're actually going to cover in one of the upcoming nuggets fully. But this is essentially the aggregation nodes I was showing you that would feed to the customers. You got your residential, your business customers, and you can reach them using a variety of methods. Now those are all aggregated, and you can see all of this, they're trying to show here, all of these things are connected typically using fiber optic cable. They're specifically talking about dense wavelength division multiplexing. What that is you can actually take one strand of fiber and you can send light over it over different frequencies. So, you can have one stream of light that's dedicated to, carrier A, and then another stream of light dedicated to carrier B, all going across the same network strand of fiber. Matter of fact, they've tested fiber optic cable, and they don't know yet how many different frequencies they can send light over, but they've sent 400 gigabits per second of bandwidth over a single network strand of fiber using DWDM, using these different frequencies of light. Now, that doesn't mean any one light spectrum can get that kind of speed yet, but who knows where this is going. I mean, we're essentially tapping light as of right now as this limitless bandwidth resource. But anyway, so we've got these nodes, if you will, these aggregation nodes that connect to our customers. So this could represent one neighborhood, and it's feeding back over a strand of fiber to our data center, which is kind of a aggregation point for the carrier. Now you see right here we have this intelligent services edge. So we have, notice all these aggregation nodes that are feeding in to kind of our central core of the service router, which is over here. It passes through this intelligent services, which I'll just say for now, this is the management. I mean, carriers and service providers are delivering a variety of services to the customers. You have voice over IP, which is now a common service, telephone service. You have internet services, ISPs that you're sending. You have television, which you're sending, streaming. I mean, carriers have long since been aggregating all these services over one single connection, and that's what's sitting at the core. I mean, that's where they have their intelligence. Here's our television servers. Here's our SIP servers. Those are voice over IP, by the way. Things that we use to control our phones. So all of those are sitting at the core, and those are the services being delivered along with, out here, is the uplinks, where this carrier, whoever it is connecting to level 3 or CenturyLink or other carriers down the way, if you will, and that's what's bringing in the internet service into them. So carriers just continue to add more and more aggregation points, and that's what allows them to grow and grow. Their customers, I mean, from a business model, their customers are paying every single month for all of these services that they are delivering, and these, the carrier pays these uplink carriers as well for their services. So I mean, that's welcome to the service provider business. But this is the design that Cisco is showing as their next generation model of how you build a service router. We're going to spend a lot of the series breaking these models down and saying, okay, well, how do you configure, this device? How do you work with these? So from asking the question of what is the network all the way down to Cisco's NGN service provider model, that's quite a progression in a matter of minutes. So I know some of this may be fuzzy for you if you're brand new in the network world. We will be unpacking it more as we go through the series. If you've had some background in networking, hopefully this filled in some of the gaps as to what it takes to build a service router and what really is going on behind the scenes. So for now, I hope this has been informative for you, and I'd like to thank you for viewing.